Good afternoon, everyone. My name is Joris Vlasblom, and it's my honor to welcome you to the Hydrogen and Fuel Cells Europe. Please have a seat. We have some very interesting topics to talk about for you today. So, getting on with that, I would like to welcome to the stage to discuss the hydrogen logistics, tanks and assemblies for hydrogen transport. From Mahytec, we have the bid manager, Mathilde Bangoura. Bangoura.
Hello.
Welcome. Thank you for joining me. Please have a seat.
Thank you.
So, tell me about Mahytec. What do you guys do, and what are you all about?
So Mahytec, it's a company that was founded now more than 15 years ago. It's a company that was founded by a professor from a French university. And our core activities is related to hydrogen storage. So we are a company that design, manufacture hydrogen tanks.
Very cool. And you're located in France, you said,
Yeah,
right?
we are located in France, in east of France, actually not so far from the German border.
Ah, okay. Very cool. And I believe Mahytec was also acquired by Hensoldt. Can you tell me a bit about this? How does the collaboration work?
Well, yeah, so around 2 years ago now, we were acquired by Hensoldt. So Hensoldt is a German group, while the head office are near from Munich. And they are, let's say, an innovative technology provider for defense and security electronics. And this company, they already had offices in France, and we were strongly collaborating with them. And so when Mahytec needed to go to the next step and increase its capital to go on, well, larger markets and also on, well, new development, we also needed to have some strong financial and some strong support from a big group. And so that's because also of the link that we had in the past, that we well made the acquisition, and so that now we are one same company, let's say.
Very interesting. And then Mahytec is making the tanks, right?
Yeah.
And then Hensoldt is doing some other stuff with it.
Exactly.
So maybe you can point to the little
Yeah,
thing here.
so
What's
Mahytec, we, as I said, manufacturing the tanks. And then within the group, we also make some assemblies of several tanks together. So in terms of bundles, but also in the shape of a 20-feet container. So for instance, this container is a 20-feet container that can store around 500 kilo of hydrogen at 500 bar. So that's a project that we are developing all together inside the Hensoldt group.
Very cool. And what are the applications for devices like this?
So I heard my colleague in the last speech were talking about multimodal container and all the nightmare that can be from the certification process. So this is a multimodal container that is designed for transporting the hydrogen by road, by train, by boat. And yeah, that's the main goal of this container. And one of the projects I could talk about is the last big project that we were awarded. It's for maritime application. So you have this container that will be taken from the transportation from the production sites. So put it on a truck, we go right to the harbor, and then from the harbor, it's directly put on the deck of the boat. So this same container goes from the hydrogen fueling station up to the boat and becomes the fuel of the boat.
So then instead of putting a hose to the boat and refueling it that way, you can simply let's say, swap the tanks in order
Yeah,
to
exactly.
refuel like that.
So the big advantage is here that we make some swapping, so we do not have to have a dispenser or big infrastructure inside the harbor. No bunkering is required. The thing is we take the empty container and replace it by a full container that is just being charged at the hydrogen production site. So yeah, that's really the advantage of having less infrastructure. Of course, it does require some certification process that is quite a long term, but I mean, that's our part of the job, so that's good for the end customer.
And is it already certified at the moment, these containers?
So the tanks are approved, and the container is also approved for for transport and also for maritime application.
Great. So if anyone here in the audience would like to have their boat run on hydrogen, they could just call you up to order a tank. Great.
So we can work on any type of boat. This one for this project is the dredger. And well, if you have the chance to go outside, you have at scale 1, the same container that is outside right at the exit of hall 13, just before hall 12. So you can see this container as well.
Good. So you can make a little field trip. So is there anyone in the audience with questions at the moment? No, if you have them, please raise your hand. Otherwise, we'll move on. So these tanks, they are pressurized hydrogen tanks, right? So what are the pressures that you operate at? Are there any other technologies that you're exploring?
So these tanks into this container, they are working at 500 bar. They come in, well, they are designed to fit into this container, but we also have different sizes available. So 500 bar is the pressure that we use for logistics. But we also work on stationary, on fixed application. And in that case, we sometimes do not need to go up to that high pressure. And so we also have tanks that are working at lower pressure. Today at 60 bar. Typically, they are used as the buffer storage of an electrolyzer. But that's only for stationary application, not for logistics. And the other application, I mean, other technologies that we work on is solid storage through metal hydride. So metal hydride, that's not compressed hydrogen. It's hydrogen that is stored into a powder, let's say. And with this technology, we can use it for stationary application and also for transport, but for the transport of very small quantity because that's quite heavy. So that's not going to be for the transport of hydrogen from hundreds of kilo. That's not going to work. But to transport or to hold 1 kilo and take it on you, then that's a good thing.
Interesting. And this metal hydride technology, what are the use cases you see for that, for this 1 kilogram hydrogen?
Well, we actually have some projects with the defense market for military, how to reduce the weight of the batteries, and they can use this metal hydride to carry it. And well, that brings more energy to the systems that they are carrying. And so that's one of the applications we see. And then for any kind of civil application as well, anyone that wants to transport hydrogen but small quantity, then that can make a match.
Okay, very cool. In the meantime, are there any questions from the audience members here? No, then let's continue. So these compressed hydrogen tanks, what sets Mahytec apart from all of the other exhibitors here in the hall today?
Sorry, what?
So what in terms of technology in the hydrogen tanks, what makes the Mahytec tanks different from the other tanks here in the hall?
Well, first of all, they are type 4 tanks. So it's a tank that is made with a polymer liner and then that we reinforce with, in that case, carbon fiber. So it's quite resistant to, for example, maritime or corrosive environments. Compared to steel, they are also lighter than steel tanks. And well, compared to other competitors, it's mostly like the kind of application that we make of it. So those tanks, they are approved for stationary and for transportable application. What makes us difference is maybe the pressure also. Most of the time you will find 350 bar or 380 bar. We made the choice to go a little bit higher and reach 500 bar pressure. Why 500 bar? Because we think that with this container, it's also a way to have like ready-to-use hydrogen at 350 bar. So you go from the 500 bar, and then through emptying cascade, then you can refill vehicles at 350 bar, so trucks, for instance, or well, any type of vehicle at 350 bar.
So you could almost use this as like a jerry can for hydrogen.
Pretty much, yeah.
That's great.
A great jerry can, a big one.
And is it only hydrogen storage that Hensoldt and Mahytec do, or is it also going a bit further, maybe into mobile power?
Yeah, well, so logistics is one big part of the market that we are in, but we are also working on more complete system that includes all of the hydrogen chains from the production, the storage, and then the electrical conversion, for example. So we also have like complete power-to-power systems. As the container, there's one also that is outside in all 13 that you can see. So yeah, it all fit into a 20-feet container, and but this time you have the production through an electrolyzer, the storage, and the fuel cell.
So it's really a ready-to-go, all-in-one system in this 20-foot container.
Yeah, the idea is to have something as compact and as standard as possible, but still you can adapt it, put more electrolyzer, or having a bigger fuel cell to adapt to the power that we need in the output. So, but yeah, the idea is going from standard products and having some standard container that can be. Well, it's mostly designed for small power application. We are not involved in megawatt projects today. It's more about the fuel cell up to 100 kilowatt power. But that's already, it can already cover a lot of application.
Yeah, so what would be a typical application for a system like that?
So I mentioned, from what I think is one of the coolest projects for hydrogen. So we have been installing now 1 year ago a dialysis center in Africa. So there was in this hospital no dialysis center because the electrical network was not good enough to support these systems. And so we installed the solar panel and one energy box. So we treat the water to produce the hydrogen. The same treated water goes also for the dialysis treatment for the patient. And so we produce the energy, but we also produce the basis for the dialysis center. And so at the end, that's like 30 people that are able to be cured into the city they live in, and that just was not possible before. And so, yeah, that's a good application on how hydrogen can be used at the service of the population. And in that case, there was no, well, there was a great acceptation of the hydrogen systems because they saw that, well, without it, it was not possible to have enough energy to make the system work, and the hydrogen here really was the solution to bring that energy that was missing.
Yeah, so really, hydrogen is keeping these people alive today.
In that, yeah,
that's
definitely.
An incredible story. And where is this project located, if I may ask?
So it's located in Kamsar. So it's a city in Guinea, in West Africa. Yeah. And yeah, it's been running now for 1 year, so it's quite cool to see how hydrogen can here save life.
Yeah, yeah, incredible. And yeah, how do you follow up on that? No, it's very interesting to see that there's also use cases for hydrogen not only in Europe, because I believe a lot of people are only looking at Europe most of the time, but it's great to see that also outside of Europe there's real life use cases
Yeah.
for
Well,
hydrogen.
it's true that our core focus here is based in Europe, but there are also many applications that can be done in other countries and in countries where the electrical power is not as reliable that it is in France or in Germany or in most in Europe. So there are plenty of applications that can be done. Industrial application, civil application, like for the people, and also, as I mentioned earlier, also military application that can be performed with hydrogen.
Yeah, so really in the remote areas where there's a limited access to or limited reliability to the grid,
Yeah.
that's where these systems really shine. All right, thank you. Are there any questions from the audience so far? Well, then maybe a good one. What's the biggest challenge that you at Mahytec and at Hensoldt are facing in developing these types of systems?
Well, I would say that certification was quite a big challenge, as this same container is used both on road, on train it could be, but also on boats, and not only to transport but also to fuel. So it's different standards that are not always working well together. So we have to work on alternative designs. So that's a big and long process. But for this project in south of France for the dredger, that's something we went through. So it's a good thing, but that's a big challenge. And yeah, so really the standards, how to follow those new standards and get the projects ready for market is a big challenge.
Yeah, so making sure that everything's safe and also, of course, certified.
Yeah.
And, but I believe you've made it, and we have not only this small scale model, but also a large scale, actual, physical entity outside. I
Yeah,
believe
we couldn't bring it on stage, so but I encourage you to go outside and see it. So we have this real container for logistics, but we also have a power-to-power system next to it. So it's quite representative on both markets that we are working on.
Yeah, and if they want to see it, where can they find you, and where can they find the container?
So we are located in booth C60, and the outside is on. So the booth number is U50, but it's just right at the exit, right before hall 12. If you go at the exit of this hall, so it's not difficult to find us.
All right, thank you. And thank you for taking the time to talk to me, Mathilde. It was a pleasure interviewing you.
My pleasure as well.
So, thank you.
Thank you.
And thank you all for being here. I highly encourage you to come have a chat with Mathilde in the stand in C60, or have a look at the full-scale model in outside at U50.